Helicopter 9-1 Basic Flight Maneuvers. Welcome to our discussion on basic flight maneuvers in helicopters. As we delve into this topic, it's crucial to acknowledge the inherent variability in helicopter performance, influenced by factors like wind, temperature, humidity, weight, and equipment. In essence, no two helicopters behave precisely the same way. Nonetheless, we'll explore these fundamental flight maneuvers in a manner applicable to the majority of helicopters, primarily focusing on small training helicopters. In most cases, the techniques outlined are tailored to helicopters with a single, counterclockwise rotating main rotor and an antitorque system. Any deviations from this norm will be duly noted. When we use the term, apply proper pedal pressure, it generally encompasses both types of rotor systems. Throughout our discussion, we'll refer to collective pitch control as collective, and cyclic pitch control as cyclic, for simplicity. Now, let's turn our attention to the core fundamentals of flight upon which all maneuvers are built: straight and level flight, turns, climbs, and descents. Proficiency in these fundamentals forms the bedrock of a pilot's skill set, as they serve as the basis for more complex maneuvers. Achieving a clear visual and mental understanding of these fundamentals is key to mastering subsequent maneuvers. As we explore each maneuver, you'll find a brief description followed by the techniques to execute it. It's important to note that we won't detail every specific attitude or movement for each maneuver, but rather provide a foundational understanding. Additionally, common errors associated with each maneuver will be discussed. Moving on to some guidelines for maneuvering flight, remember to operate the cyclic only as fast as trim, torque, and rotor speed can be maintained. Anticipate changes in aircraft performance due to loading or environmental conditions. Awareness of flight characteristics during maneuvering flight, such as torque changes in turns and the effects of cyclic input, is crucial. Always leave room for unexpected situations, stay aware of wind conditions, and understand that engine failures can occur during power changes. Crew coordination is paramount, and in steep turns, anticipate the nose drop effect. Normal helicopter landings often require high power settings, and the cyclic position relative to the horizon determines the helicopter's travel and attitude. As we proceed, keep in mind the intricacies of helicopter flight and the importance of mastering these fundamentals. If you have any questions or thoughts, feel free to engage in our discussion. Now, let's delve into the intricacies of straight and level flight. This form of flight involves maintaining a constant altitude and heading, where the rotor disc's attitude relative to the horizon dictates airspeed. Altitude control primarily relies on the collective. To initiate forward flight, the rotor tip path plane must tilt forward, prompting the helicopter's nose to lower and increasing airspeed. To counteract this, the pilot adjusts the collective to find the right power setting for level flight. The horizontal stabilizer aids in trimming the helicopter, reducing nose tuck. Any collective change necessitates a coordinated throttle adjustment to maintain constant RPM, with anti-torque pedals used to keep the helicopter in trim. Increasing airspeed involves applying forward cyclic pressure and raising the collective, while decreasing airspeed requires rearward cyclic pressure and lowering the collective to maintain altitude. Maintaining straight and level flight involves using the natural horizon as a reference. If the horizon rises, slight power may be needed, or the nose might be too low. Conversely, if the horizon drops, reduce power or adjust the nose, indicating it may be too high. While the cyclic is sensitive, a slight delay exists in control reaction, requiring anticipation of actual helicopter movement. Overcontrol should be avoided, and corrections must be made promptly. If the nose rises too much, apply forward cyclic pressure to correct, and return to neutral slightly before reaching the desired attitude. Given the inherent instability of helicopters, pilots must stay vigilant, as any deviation tends to persist. Now, let's address some common errors. Failure to trim the helicopter properly, leading to cross-controlling. Neglecting to maintain the desired airspeed. Failing to hold the proper control position to maintain the desired ground track. Insufficiently allowing the helicopter to stabilize at the new airspeed. Moving on to turns, this maneuver facilitates a change in the helicopter's heading. Before initiating a turn, clear the area in the intended direction. To start a turn, apply sideward pressure on the cyclic, avoiding pedal use for turning assistance. Pedals are solely for torque compensation to keep the helicopter in trim. The bank's speed depends on lateral cyclic pressure, and the degree of bank depends on how long the cyclic is displaced. After establishing the desired bank angle, return the cyclic towards neutral to maintain that angle. Increase collective and throttle to maintain altitude and RPM, adjusting pedal pressure for torque. Rolling out of the turn involves applying pressure in the opposite direction. Start the rollout before reaching the desired heading to counter the helicopter's continued turning. Level turns also apply to climbing or descending turns. Simultaneous entries combine climb or descent with a turn entry technique. When recovering from climbing or descending turns, reaching the desired heading and altitude rarely occurs simultaneously. Now, let's touch on slips and skids. A slip occurs when the helicopter slides sideways towards the turn center due to improper anti-torque pedal pressure. In contrast, a skid happens when the helicopter slides away from the turn center due to excessive anti-torque pedal pressure. In summary, a skid arises when the turn rate exceeds the bank, while a slip occurs when the turn rate is too low for the bank. These concepts are fundamental to mastering helicopter maneuvers.